Hello children, today my class is for the 10th standard, especially for those who are answering ICSE examinations. So I'm going to discuss the challenging questions that came in the 90's in ICSE on locus constructions. Okay, hope it helps you, and it also will give you an idea how to tackle sums which are given in this manner, right? And before I start, I just want to say that failure is always followed by success if there is no full stop, right? So the first question which came in the 90's on locus construction is: construct a triangle PQR, angle P is 40 degrees, angle Q is 60 degrees, and the circumradius of this of the circle to this triangle is 3.5 centimeters. So you cannot draw a triangle when two angles are given. That means you know the third angle. The angles are 40, 60, so the third angle is 80. AAA is not sufficient to make a construction of a triangle. So that is why the circumradius is given. So circumradius is radius of that circle which circumscribes the triangle PQR. Okay? And the circumcenter is a point of intersection of the right bisectors, that is perpendicular bisectors of the three sides of the triangle. One more thing also you should know, that the circumcenter is equidistant from all three vertices of the triangle. So if they say construct a triangle with the data given and locate a point P which is equidistant from all three vertices of the triangle, and also assign a special name to P. So you have to just construct the triangle with the given data, draw perpendicular bisectors of not all three sides, any two sides of the triangle, and where they meet, that is the point P. And that is nothing else but the circumcenter of the triangle. Am I right? So in this case, first I'll make the circle, okay, whose radius is given as 3.5 centimeters. That means it is the triangle, after you construct the triangle PQR, and this is the circle circumscribing it. So that's why it's called circumradius. So here, first you make the circle of radius 3.5 centimeters, and then you add the center O, mark this as O, and let this point be X. Now we don't know where is PQR yet, right? So first you'll take angle P, whatever the angles given, the two angles given, you take double the angle, okay? 40, double of 40 is 80, and 60, double of 60 is 120, and these angles you have to construct at the center. So for 120 you don't need you can do just with a compass. You can also make 80 first, that doesn't matter. So here you'll make an arc, O as a center, and cut same radius, same arc radius, you cut in three equal parts, right? You know that this is semicircle and you are cut into three equal arcs. So 180 divided by 3 will become 60 degrees. Based on the theorem, equal arcs subtend equal angles at the center. That is why 60 and 60 is 120. So you will join O and this, of course, the second arc, because 120, this is O center, and this, let's say, Z. So angle XOY is 120, double of angle Q. Then taking OY as the baseline, and here you cannot make 80 degrees double of 40 with a compass, so you can use a protractor. It was given you can use a protractor in that question. If had it been 45 degrees, it will be only using compass, because double of 45 is 90. You can make a 90 degree angle using a compass. Okay. So now you will make here with a compass, putting the compass here the center. You will measure 80 with the compass. So this is your 80 degrees, double of 40, and let us name this as Z. Now join the 3 points which you get, X, Y and Z. So angle XOY is 120 degrees, YOZ is 80 degrees. So the one opposite to angle ZOY and join XZ also, sorry. This angle will become 40. Angle subtended by an arc at the center of the circle is double the angle subtended by the same arc on the circumference of the circle. That is the reason we made double the angle. Got it? And here angle YOX is 120 degrees, which is made by this arc, minor arc XY, and therefore its half is angle YZX. So this becomes 60 degrees. Angle subtended by an arc at the center of the circle, which is 120, is double the angle subtended by the same arc on the circumference of the circle. So this is 60. So which was my 60 degrees? My angle Q. So Z is actually the vertex Q of the triangle. X is the vertex P of the triangle. Of course, this becomes R of the triangle. And measure any of the sides. Got it? So we made a circle whose circumradius was given 3.5 centimeters. Then the triangle cannot be constructed before the circle is drawn, and you at the center you make double the angles given, that is 120 and 80. 80 you can use protractor, you have to use protractor. 120, and where they intersect you got the 3 points, join them, and that becomes the triangle PQR. But please be careful which one you name as P, which one is Q, which one. You cannot name any vertex as PQR. Okay, the one which is just opposite to 80, that is 40. You know angle at the center theorem, right? So, and one which is 120, that is angle POR. Its half is this angle Q, which is 60 degrees. And that's how this construction is completed. Got it? The next construction, again that too, this also came in compulsory section of 4 marks. And another question which came, of course not the same year, okay, on a rectangle but based on locus, right? And also in compulsory section. So that was construct a rectangle ABCD. You can write down as I'm saying, construct a rectangle ABCD where AB is given as say 4 centimeters, whatever the measurement is, doesn't matter what was given then. Okay, so construct a rectangle. Okay, ABCD. Now what were the things given? One, rectangle. It's rectangle ABCD. AB is say 5 centimeters, right? And there's a point P. A point P is equidistant. P is a point equidistant from AB and AD. Third point, P is also equidistant from B and C. And fourth, AP is given as 2.5 centimeters. Measure the side BC, or they can ask you find the perimeter of the rectangle. Is it clear? So, in this, reading the question, now always whenever construction is given, children, always make a rough sketch. Okay? When we make a building, we have a plan made before the building is made, right? Similarly, it gives an idea what to do, right? And give 5 minutes to think about which theorem I'm going to apply, how I'm going to solve this or construct this particular problem. Okay? So, now you got the data, A, B, C, D, one side is given, right? And all angles are 90, you know that you are supposed to know. And P is one point which is equidistant from 2 sides of the rectangle and also equidistant from 2 vertices of the rectangle, which is B and C, and 2 sides is AB and AD, right? And AP is given. So here, after reading this, now I'll make the question. So first I'll explain the rough sketch. Oh, what do we do? So you don't know the position of C and D. You only know AB. So this is the rectangle. I don't know which is big, which is small. I only know this is 5 centimeters. These are 90s. And P is, where is C, where is D? I do not know. Okay, because I do not know the length. So, but I know but the D lies along this length, along the line, because it is perpendicular to AB. And C also lies along this line because BC is perpendicular to AB. But we don't know its location, right? So first you'll make AB with compass, you measure it and make this 5 centimeters as I've given. Then construct 90 angle with using a compass. You know how to do that. So you got this. So let's call this as X and Y. On BY you have C, on AX you have D, right? So now P is equidistant from AB and this line because D will lie here. So you'll make angular bisector. But you cannot locate where is P. This is angular bisector. Don't think many people did this. Where the angular bisector, that is C. But diagonals of a rectangle do not bisect the angles. Okay? A rectangle which is a square only bisects. See here children. The diagonals do not bisect the angle. So don't think where it be that is C. That's incorrect. Okay? C cannot be on the angular bisector. So don't think this is C. No, that is not C. So, and it is given AP is 2.5. So from A, taking center of the arc, take arc length as 2.5 centimeter where I gave AP is 2.5. So there you can locate P now. Otherwise you cannot locate P. So two loci meet, then only you get a point. With one locus you cannot locate a particular point. So here you have AP. Also this question can be given this way. Instead of saying AP is 2.5 centimeters, P is a point which is at a distance of 2.5 meters from the point A. So anything which is moving at a fixed distance from a fixed point will be a circle. So then you'll make a circle, and where the circle and angular bisector meet, that becomes P. Now the second point is given that P is equidistant from B and C. See, we people always know one direction solutions. Like A plus B whole square is A square plus B square plus 2AB. But suddenly if I ask you what is A square plus B square plus 2AB, you will think. Both ways you should know children. Both ways of mathematics. If I give you a line AB equidistant from AB, you say, oh, perpendicular bisector. But now I know the point, one point on the perpendicular bisector, I know this, but I don't know this. So, what is the meaning of equidistant from A and B? This distance is equal to this distance, that's all. Right? Why are you thinking of perpendicular bisector? How can you bisect a line when you don't know the other end of the point, other end of the line? You cannot find the bisector. Okay? You can draw bisector of a line segment, not of a line. Right? So, here you are drawing AP. Now, P is equidistant from B and C. I don't know where is C. But it will be on this line BY. So you just measure with the compass this distance with a compass. Turn the compass because same distance, cut it here. It cuts here. So that is your C. So this distance, you know P, this distance is equal to this distance. That's all. Don't take a scale to measure. Just take a compass, put it here and measure this distance. Turn the compass and cut it on this. So same distance. Whatever is this distance, from P same distance. So this. And you got BC. So once you know BC, you can measure this. And same measurement, you measure this. And from here you cut it. That is your D, which will be opposite. So this completes your rectangle. Right? So EP is equidistant from B and C. C I do not know. So from P I measure this distance with the compass, turn your compass and cut on the line BY. That's your C. So isosceles triangle you're making, that's all. Why you're thinking that I have to make a perpendicular bisector when P is equidistant from B and C? But children, I do not know where is C. So you cannot make a perpendicular bisector of a line whose length you do not know, of a line segment. Okay, but I don't know the length of the segment. Right? So, but distance I know, I got B. So, this distance you cut it here. That's your C and therefore you get the triangle. This is your C and join it. Therefore, this distance, what do you get? Opposite sides are equal of a rectangle. You cut it, that's all. And that completes your construction number 2. What about the third one? The third one is even more difficult. So, what is the third construction which I am going to discuss and what was challenging? A little difficult for many of the students. I am not saying all of them did not do it because we do not like locus and we really do not understand locus. Okay, and it is few locus you by heart and go and you decided that I am not going to do locus. But what happens if it is given in the compulsory section? You have to always prepare for the worst in life to be happy in future. Always that is the thing you have to learn, children. You cannot have the best of everything, then you'll never be happy in future. Right? So, because you have not faced the worst, let us see the third question. Okay. Construct a triangle. Again, third one. Construct a triangle ABC. Say AB is say 6 centimeters. Angle is, I'm just giving an example, 60 degrees. And in radius is say 2.2 centimeters. In radius is the radius of the incircle. What is an incircle? An incircle is a circle touching inside the triangle, okay, touching all three sides, and its center, which is called incenter, is equidistant from all three sides of a triangle. So what is incenter? It is point of intersection of angular bisectors of the three angles of a triangle. Okay, incenter is always equidistant from all three sides of the triangle. If the question says construct a triangle and not to make an incircle, just they say locate a point X which is equidistant from all three sides of the triangle. You constructed the triangle with the data given, and you just have to locate a point X which is equidistant from three sides of a triangle. So that is incenter, that is your X. X is your incenter, so you have to make angular bisectors of two angles, not required for three. And where they meet, that is your incenter. You don't have to make the incircle for it. As I said, locate a point X which is equidistant from three sides of a triangle. In this one, it is a little difficult because the triangle you cannot make. First, you have to make the incircle. Okay. So actually, this is the diagram. After, we don't know the triangle. We only know AB. We know this. I told you rough sketch. We know this is how much? 6 centimeters. And the circle which is touching all three sides is incircle. And this is the center, incenter. And this distance is equal to this distance is equal to this distance. And all three are radii. That is in radius. So IN, IM and IT are radii of the circle. So equidistant from all, because tangent is perpendicular to the radius at the point of contact. So therefore that becomes the shortest distance, and that is the distance which is the radius. So it's equidistant from all three sides of the triangle. So listen to this, that this is center. Because it's touching a line, what is the locus of center of a circle, which I discussed in my locus 3 videos I have given you on locus, children. Please see that. Okay. So here, what is the locus of center of circle? Touching a line. So it's touching a line. Okay. It is a line parallel. The locus of this center is a line parallel to any of the side of the triangle at a distance equal to the radius. Okay. So first, this is the picture of what I have to get. But problem is, how do you do the sum? So how do you do the construction? So first you make AB, whose length is given. So we just draw a line, cut an arc of, how much is that? It was 6 centimeters I said, whatever the length is. Then angle is 60, whatever the angle is. 60, right? I have to locate C now. C is the problem. So in radius, it is touching, a circle is touching a line, a wheel is going on the road. So the center will always be on a line parallel to the tangent at a distance equal to the radius. You know the circle, the incircle touches every side of the triangle. So now since AB is given, I'll draw a line parallel to this. So already 60, you can make 90 anywhere. So suppose I continue 90 here and make another 90, not at B, anywhere you can make parallel line, just a line parallel to a given line. You can make 90 this way also after 2.4, and here you make, now you cut 2.2 because that is the radius. 2.2 is the in radius, and then join this. So you get a line XY where the in center will lie, because its distance from AB, which it will be touching the side, will be 2.2. So now you don't know, this is, so this, children, this is angular bisector. So in center is, this is not angular bisector. Now you'll make in center is point of intersection of angular bisector. So 60, this angle was 60. Now next step, construct angular bisector of 60. Where it cuts XY, that is your in center. Not angle A. C will lie somewhere here. So AY, let's suppose, on AY C will lie. That CAB or YAB is 60 degrees. But in center will always lie on angular bisector. So angular bisector of 60, I make the bisector of angle A. Okay, where it cuts this line XY is your in center. Right? And then join it to B. And angle IBA will be half angle B. Because it's angular bisector again. BI is angular bisector. So what you will do, you have this IBA. So what you do is make an arc and measure this much. So you make an equal angle. You know how to copy an angle? So you cut an arc on this. So this is half B. This is half of angle B. So make an arc big and measure this gap with compass, and from here you cut it. Again I'll tell you, this is B, half B. Okay, this is I. Just extend this arc, measure this gap with a compass and just cut this. Whatever this angle is, you make this angle, copy this angle. So this also is B by 2, this is also B by 2. So I made other half B, so on this. So here you have, I'll rub it so that it doesn't look so confusing. So this was my B by 2. So I'll extend the arc, copy this angle here, half the angle, join this, produce it to AY, that is your C. So this is B by 2 and this is B by 2. This is B. That's how you get the third vertex. Is it clear? You got the third vertex. So you have, just to repeat this, you made AB, then you made angle 60. Okay, in center will always be on angular bisector, so you made this. In center will always be equidistant from a given line, so you make a line parallel to AB, making two 90's at a distance of 2.2, where the angular bisector meets this parallel line XY, that is your in center, and you join IB. So this half of angle B, extend this arc, copy this half here, this gap, this angle you copy it here and join it, and that is your C. So other half you make, this half you are making it, this is the given half, and produce that where it meets AY, that is your C. So that's how you get this triangle. Hope you understood, children. So just read it out. If any problem, you can just message me. Thank you, all the best. Nothing to